day viewers, you're welcome to my YouTube channel. This is Chem Easy, and today I'll be doing a brief demonstration on the WAEC 2023 chemistry practical. First, I'll start with the preparation of the reagent. I'll teach you how to prepare the reagent, to calculate the concentration, and also to titrate it against the base. It involves hydrochloric acid and sodium carbonate dihydrate. So it will be in two phases. The other phase will be sample questions you may likely see in your exam. As usual, I did that for NECO practical and the previous one. You can see the accuracy close to 95% accuracy. You can go to the comment below in those videos and you see wonderful comment there. So I will urge you to first subscribe to my YouTube channel. As I said, it will be in two phases. Those first phase will be free to everybody, but the other video that will come that has to do with sample question and calculation will only be sent to my YouTube subscribers. So please, I will advise you to subscribe to my YouTube channel, and a lot has been put into this to ensure you understand it in a layman, giving you a layman understanding of how you can calculate the concentration, you can prepare it, and also titrate it for the base. Alright, thanks.
Alright, we'll start with the preparation of the standard solution from the instructional materials. As you can see here, this is 2023 WAEC chemistry instructional materials. Alright, so these are the information in your instructional materials. The A part of it says you should have 150 cm cube of a solution of HCl in a corked flask or bottle labeled AN, and this should all be the same containing 8.5 cm cube of concentrated HCl per dm cube. That means we should measure at 8.5 cm cube of the concentrated hydrochloric acid, then we'll dilute to 1 dm cube, which is per dm cube. Okay, and you should note that 1 dm cube is equivalent to 1000 cm cube. Alright, take note of that. So we'll measure at 8.5 cm cube, then we'll dilute to 1000 dm cube. If you do that, what would be the concentration of the reaction? So we'll start by calculating our various concentration before we go over to the practical in proper. And so the first one we'll be dealing with is the acid, and it's measuring 8.5 cm cube of HCl in, and we dilute to 1000 cm cube, 1000 cm cube with distilled water. So what will be the concentration? So you use your normal dilution formula, which is C1 V1 equal to C2 V2. Alright, now your C1 is your initial concentration. Every stock solution of HCl comes with an initial concentration of 12 mole. Alright, so take note of that. Our C1 is 12, while your V1 is your initial volume, which is the volume you measured from the stock solution. Alright, and it's 8.5, so it's 8.5 cm cube, and our C2 is the final concentration after diluting it, is unknown. Then V2 is the final volume we want to dilute to, which is 1 dm cube. Take note, I said 1 dm cube is equivalent to 1000 cm cube. So this is 1000 cm cube. Alright, so if you do that by substituting into the formula C1 V1 equal to C2 V2, our C1 is 12 times our V1 is 8.5 equal to C2. You're looking for C2 times our V2, which is 1000. Alright, I believe you're following. So now to do that, we divide both sides by, to have C2, which is what we are looking for, we divide both sides by 1000. So we divide this side by 1000. This one goes into this one. You should have C2 equal to 12 times 8.5 over 1000. Okay, so when you do that, 12 times 8.5 over 1000, that is let me pop out my calculator. 12 times 8.5. Alright, you see it is 102. We have 102 divided by 1000. 102 divided by 1000. So 102 divide 1000. So this is the concentration of the acid, which is C2 is 0.102 mole per dm cube. Alright, so we'll go over to how we can prepare this, but take note the concentration of your acid is 0.120 mole per dm cube. Alright, so we'll go over to the other part of it, the basic salt here, which is sodium trihydrocarbonate 4 decahydrate in a cork flask or bottle labeled BN. So this should all be the same, containing 5 grams per dm cube. Alright, so for our BN, we are having for BN we should dissolve 5 grams of Na2CO3 decahydrate in 1000 cm cube. We dilute 1000 cm cube and then we calculate the concentration. And how do you do that? For you to get, if you dissolve 5 grams of this in 1000 cm cube, this will be the concentration of the solution. Alright, this we can calculate that using this formula. Concentration is equal to mass over molar mass times 1000 over volume. Alright, so now let's go and let's calculate this. Concentration is concentration we are looking for. Concentration, what's the mass? Our mass is 5 grams. Then our molar mass, what's the molar mass of sodium carbonate decahydrate? And I believe you can do that very well. That is Na2CO3.10H2O. Alright, the mass of sodium is 23 times 2, you should have 46, plus carbon is 12, the mass, oxygen is 16 times 3, you have 48. Alright, plus 10 water, 10, hydrogen is 1 times 2, you have 2, plus oxygen is 16. Alright, so if you have 46 plus 12 plus 48 plus 10 times 2 plus 16, you have 18. 10 times 16, you have 180. So when you sum everything together, your mass is approximately 286 grams per mole. That's the molar mass of it. So our molar mass, let me clean this off. Okay, so our molar mass, the molar mass of molar mass becomes 286 grams per mole. Alright, and the volume we are diluting to 1000 dm cube, so we have 1000. Alright, so let's substitute into the equation. Concentration equal to mass, the mass is 5 grams over the molar mass, which is 286 grams per mole, times 1000, okay, over the volume is 1000. That is a dm cube. Alright, so this goes cancel this. So 5 divided by this, the concentration of our Bn, if 5 divide 286, so here we have 5 divided by 286, we have 0.0175 approximately. Alright, so Bn becomes 0.0175 mole per dm cube. So we'll go further to prepare this solution. Alright, so just watch the video, and please, if you've not subscribed to my YouTube channel, just do that quickly. Thank you. Alright, here is our HCl, our stock solution. So we pour out a little quantity from it. It contains 12 molar concentration. Then here is a measuring cylinder, 10 ml capacity. We'll measure at 8.5 cm cube accurately from it. And here is a standard volumetric flask, 1000 ml capacity. First, you pour little water into it first. Take note, you add acid to water, so that is why we're adding water to the standard volumetric flask. Adding more water to it before you add your acid. Or you can now add your acid to it, your 8.5 cm cube, and then you dilute to the 1000 mark. Rinse it to remove more quantity from it, and now you dilute to the 1000 mark. It has a mark there, I believe you can see it. Dilute to the 1000 mark, so that is per dm cube. So these are 0.102 mole per dm cube of hydrochloric acid. Alright, we shall go further to prepare our PN. There is weighing balance, or digital weighing balance. We add 5 grams of sodium carbonate dehydrate. This 3.3, this 4.5.3, so you need to adjust. Okay. Alright, this 5.0, as you can see it. So we'll go further. First, you dissolve in water, then you dilute to 1000. Alright, don't just pour 1000 and add the solid to it, it will increase the volume, but rather dissolve it in water first. As you can see what I'm doing, dissolve in water, you stir, ensure it dissolves properly. It's highly soluble in water, so that won't be a problem. Then after that, you turn to your standard volumetric flask. Right after dissolving, then you can dilute to the 1000 mark. That's 1000 cm cube. So these are our BN, which is 0.0175 mole per dm cube. Okay, so when you're done with this, what becomes the end point of the reaction? This is how you calculate end point of a reaction. You can calculate that from this stoichiometric relationship between the BN, which is sodium carbonate dehydrate, and your AN, which is the acid, hydrochloric acid. All right, the ratio is 1:2. 1 mole of this reacting with 2 moles of this. All right, so you can have the average volume of acid use, which is your end point, by using there are a lot of ways you can do that, but let me use the formula alternative method, which is quite very simple for you to understand. It's given as CAVA over CBVB equal to NA over NB, where Ca is the concentration of your acid, and from our calculation, our Ca is 0.102 mole per dm cube, and our Va, which is what we are looking for, the end point, the average volume of acid that can neutralize your Bn. So your Va is unknown, we're looking for it. Now your Cb, which is your the concentration of the Bn that we calculated. From there we have it as 0.0175 mole per dm cube, and your Vb is the volume of the beads, and you can get that from your pipette. All right, I believe most secondary school, their pipette comes with a capacity of 25 cm cube. That's the volume of your pipette. Some can be 20, but I prefer using the 25 cm cube pipette. So your Vb is 25. Take note, if you are using 20 capacity volume of pipette, you use 20 here. All right, but we are using the 25 here. All right, so our Nb is the number of moles of your Bn. All right, which is this one. You see, the number of moles here is 1, which is what we have here, so becomes 1. Then our Na, which is the number of moles we have here, is 2. So Na becomes what? 2. So we substitute into this equation. Our Ca is 0.102 mole per dm cube times volume of acid. That's what we're looking for, all over your Cb 0.0175 mole per dm cube times 25 equals to Na is 2 over 1. So to get your Va, you cross multiply, which is if you do that, you have 0.102 mole per dm cube times Va times 1 equal to 0.0175 mole per dm cube times 25 times 25 times 2. Okay, so since we are looking for Va, we divide both sides by the coefficient of Va, which is 0.102. so divide both sides by 0.102 over 0.102 mole per dm cube. Alright, take note, this volume is in cm cube here, so mole per dm cube, we cancel this out. So our Va now becomes 0.0175 mole per dm cube times 25 cm cube times 2 over 0.102 mole per dm cube. Alright, this one cancel this. So if you do the calculation, let's do it together, that is 0.0175 times 25 times 2. Alright, we have 0.875. now we divide it with divided by 0.102. we have 8.5, approximately 8.57 or 8.60. so your endpoint should be 8.60 cm cube. That is from the calculation. So when you want to do your titration, your endpoint should fall within this range. Take note of this, all right, because from the stoichiometric calculation and relationship, it tells you that the average volume of acid needed to neutralize 25 cm cube of the base is 8.60. so this is your Va. All right, so jot that down.
So we should proceed further to the titration. Here is our BN, the base. You turn a little to your beaker. You prepare 25 cm cube from it. You adjust to the meniscus. That's 25 cm cube. The first conical flax. Then you want to measure to the other conical flax. Alright. So you adjust to the meniscus also. Into the other conical flax. And after that, you add your indicator, which in this case is methyl orange, 2 drops of indicator. Alright, it's there. And then you fill your bullet with your A and your acid to the 0 mark. Take readings at the meniscus at eye level. Alright, then you titrate the acid against the base. I want to change my acid. I see it very well. You swirl it while you titrating it to ensure it have an homogeneous mixture. Alright, so your endpoint should be orange color. You should be very careful because the difference between the orange color and the golden yellow is slight. So I want to compare it. Now you see this is the golden yellow, while that's the orange color, so that should be your endpoint. Okay.
Alright, so here is how you tabulate your readings. Please take note of this, especially for those of you that are students. You don't just write your table anyhow, or you just go over to titration reading and you start filling your table. No, this is the first thing you do. And also to chemistry teachers, when you want to educate your students, alright, first you start by stating the size of pipette used. Alright, so you come, you said size of pipette, size of our pipette used. Alright, this is the first thing you write as a student. Okay, take note of that. Is 25 cm cube. Alright, then the next thing you have to write is indicator used. Ensure on your paper you state this out correctly. Indicator used. Alright, the indicator you're using is methyl orange, since the strong acid and the weaker basic salt. Methyl orange as your indicator. Alright, take note of these two things. You start like this first, then you go over to your titration reading, then you write titration reading, then you draw your table accurately in this manner. Bullet reading, your final reading, your initial reading, and average volume of acid used, which is your AN. Alright, initial reading means where you started from. You know your bullet ranges from the 0 mark to from 0 mark, from 0 cm cube to 50 cm cube. That's the capacity of your bullet. So you will fill up to 0. It means you're starting from 0. You are taking reading at the medical. So that is your initial reading. You come here, you write 0.00. You don't need to write cm cube because as long as you have cm cube at the top of the column here. Alright, but and take note, it must be to 2 decimal places. 2 decimal places. Don't go and write it like this. No, it is wrong. Don't do it that way. Or you write it just like this. It is wrong. Take note, it must be to 2 decimal places. And then from when you do the titration, I think you should be arriving at let's say, okay, this is rough, you are not being careful enough. Let's say your final reading after running it, you ended at 10 cm cube. You come to your final reading, you indicate 10.00 cm cube. Now to get the averages, this minus this, the 10 minus the 0.0, you have 10.00 here. Alright, now let's go to the first reading where you will be very careful enough. Okay, and okay, let's assume from your titration you probably fill back to 0.00. That means after you took the rough, you fill it back to 0.0, and after titrating, let's say you arrived at 8.70 as a cm cube. You put the final reading here. Then when you subtract, you also have 8.0 cm cube. You can decide to fill back to 0.0 and run it again, but it might consume your time. All right, so if you want to avoid that, you can just drain it to 9.0 and continue from 9.0. That means after stopping at 8.70, just reduce it so that you start at the round figure of 9.00. You can start as your initial here. Instead of filling back to 0, it might consume your time, so you can start here and run it. If you do that, you should be arriving at 17.60. Then when you subtract 17.60 minus 9.00, you should have 8.60. all right, and instead of filling back again, you can just drain it back. Let's say you ended at 17.60. You can just adjust it to let's say 18.00 and do it again. So your initial means you are starting from 18.00. okay, and by the time you continue with that 18.00, you'll be arriving at 25.60. all right, 25.60. so you should have your 25.60 here. When you subtract, you should have arrive at 8.50. all right, but if you know this will be confused, you can fill back to 0.00 and do your normal or you can, after you're done with this one, you repeat it again by filling to 0.00. I believe you understand what I'm trying to explain here. All right, so please take note of that. It's very, very useful. Let me wipe this off. Okay, so when you're done with this, you calculate. The first thing you have to calculate, you see it in your question, and I'll give you sample question. That is why you ought to subscribe to my YouTube channel, because that one is very important, and I may want to send it to only my subscribers. All right, you calculate the average volume of acid used. Average volume of acid used. Okay, I take note here is not supposed to be average volume of acid. You can remove this average and just indicate the volume of acid used. Then later, after everything, you calculate the average. You are taking the average volume of acid used. Now, when you want to take the average, look for the two concordant titral value. That means the values that are close enough to each other, not more than or less than 0.20. Now imagine here I'm having 8.60 and I'm having 8.90. You see the difference is much. The difference is about 0.30. all right, it should not exceed 0.20, the difference between both of them. So these two are not concordant. You don't need to take these go with these two value. All right, but let's say, like you see, 8.60 and 8.50, the difference between both of them is just 0.10. It falls within this range. All right, so you can take these two. All right, but let's assume here you have all fall within this range. You can just take the 3 and divide by 3, but for the sake of the calculation, let's just go with these two since they are very close to each other. Okay, so if we are to go with that 2, it becomes you taking the average now, 8.60 plus 8.50 divided by 2, because you are using just the 2 the second and the third reading. If you are using the 3, you divide by 3, but since you're using 2, you divide by 2. So if you divide by 2, you should have 8.55 cm cube. All right, this becomes your VA, which is the average volume of acid used. VA, you know, from our calculation, we from the stoichiometric calculation, from the equation, we arrive at VA to be 8.8. I think it should be 8.5. All right, now we are having 8.55, almost the same range. So you can go with this one. So take note, the calculation we'll be doing subsequently after now we shall be using we shall be using this as our VA for our calculation. All right, and that will be the next video. All right, thanks for watching, and please do subscribe to my YouTube channel. Thank you.